So here I will tell you the discussion which we already had. Okay. So where you can refer that discussion in this book, though all the content you will not get, but part of discussion you can for the part of the discussion you can have a description in this book. So as I suggested you to go to the unit 1, hopefully you have gone through that. Okay. In unit 1 there is a basic discussion on the remote sensing. What are the fundamental principles, like how remote sensing evolved, okay, and how the terminology like electromagnetic energy, data acquisition, data analysis, all these are defined. Okay, we have already discussed about this table. This figure 1.1, it's a entire workflow where there is a discussion about data acquisition to data analysis. Fine. Unit 1, section 1.2 talks about energy sources and radiation principles. And I suggested you to read. Remember the name of the spectral band along with the range. Let's say if I say this is a visible spectrum, then what is the wavelength range in which the visible spectrum lies? Similarly for NIR, mid-infrared, thermal infrared, and microwave. Then general physics related to the electromagnetic radiation. Then you can get discussion on Stephen Boltzmann law over here, m equal to sigma T to the power 4. That is energy radiated from a black body that is having average surface temperature T. Okay. Then after that, we had discussion on this graph that talks about variation of spectral radiant excitance with respect to wavelength. Now, if you see over here, so there is a discussion on reflected energy and emitted energy. And I told that there is a difference between these two energy components. So brief about that discussion, brief description you will get over here. And even you can see over here the general dividing line between reflected and emitted IR wavelength is approximately 3 micrometer. It is mentioned in this paragraph. Okay, but the detailed analysis of significance of 3 micrometer dividing line on the basis of how we can see in upwelling radiance or energy that is going outward from a surface. So that outgoing energy is comprised of which component, whether it is only the reflected or radiated or both contents are there. Okay, so we also had a additional discussion over this. Then energy interactions in the atmosphere. Here you will get discussion on two major phenomena, that is scattering and absorption. The figure 1.5, this is very important figure. Okay, where the A part talks about like the radiated energy curve with respect to wavelength, and B part tells about how atmosphere behaves. Okay, and it is plotted in terms of atmospheric transmissions versus wavelength. So to get energy that is reaching at the Earth's surface, what you need to do? You need to multiply graph A to graph B. So graph A is exact energy that is that leaves the surface of sun. When it enters into the Earth atmosphere, there are the losses. Okay, and those losses are recorded in terms of transmissions versus wavelength plot over here. So resultant that you will get at the Earth surface. So just see, At the sense, at the source, that is sun, what is the energy? At the target, that is earth surface, what is the energy? So at the target, the energy you will get, that is multiplication of these two graph. Then after that, at the surface, there is a division of incident energy into reflected, transmitted, as well as absorbed energy, and it is given over here, section 4, 1.4, I think it is. So energy interactions with this earth surface features. So it is mentioned over here, by applying law of conservation of energy, total incident energy is divided into various energy component in a particular proportion. Proportion means like the incident energy is the function of wavelength. If you change the lambda, what will happen? The contribution of the proportion in which the EI is divided into reflected, absorbed, and transmitted energy component, that proportion will change. Okay. And even if you change the surface, like change the type of features. If we consider we have a pixel from a vegetation and we have a pixel from the soil. So these two are the different objects. Their physical and chemical properties are different. If you remember, we also discussed about the proportion in which the incident energy is divided. That proportion will change with respect to change in the type of object, and it also change with the change in wavelength. So we have two parameters that govern the proportion in which the EI is divided. Incident energy is divided into multiple energy components. That proportion is dependent on the wavelength. Even if you have the same material, but they are observed at a different wavelength, so this proportion will change. By the way, could you tell me what do you mean by proportion over here that I'm talking? Anyone can tell about it?
Sir, proportion of reflected, transmitted, and absorbed energies.
Meaning a proportion is, let's say, if you consider the entity left-hand side, that is incident energy is 100%, fine. Yes, so sir. This 100% energy is divided into reflected, let's say it is 50%, plus absorbed, it is 20%, and transmitted is 30%. So this is the percentage in which it is EI is divided. It is called as proportion. It is a meaning of sense of proportion over here. Okay. So in a three-part, 100% energy is divided. So at a particular wavelength, let's say division is, the proportion is 50, 20, and 30. If you change the wavelength, even the feature is same. Okay. It could be the proportion could be changed. It could be 40, 40, 30, and 40, 30, and again 30. Briefly, after completing this, discussion on this book, I will again discuss this part. What I feel the discussion should be done again. Now, if you see figure 1.7, there is a discussion on types of reflection. Okay, so it's a geometrical interaction, the way incident energy is reflected back. Okay, and what is the role of target geometry over there? So that is discussed over here. Then you can get a discussion on reflectance, spectral reflectance. That is a ratio of reflected energy and incident energy. Now this is a spectral signature of vegetation. Specifically, it is for the trees, deciduous and coniferous trees, figure 1.8. Now, these are the general discussion based on the figures which were taken from different satellite program and from the different test site to explain the fundamentals which are already discussed before. Okay. Now we'll see the next unit. Yes, come to this point, A to D converter. At the sensor, what happens? So spectral response pattern in terms of spectral signature for water, vegetation, soil, snow, we have already discussed before. You can refer these para in section 1.4 that talks about energy interaction with our surface features. You will get discussion on that. Now again, there is a discussion on atmospheric influence on a spectral response pattern. Fine. So as you see in one of the lecture, we discussed about how in the energy that is reflected back, or that is outgoing energy. I should not say only the reflected energy, because the outgoing energy from the surface could be reflected or radiated, a combination of these two. So energy that is outgoing towards target sensor over here, as you see in the figure. So though they mention only the reflected component, and it can be if the sensor wavelength, the sensor which we are using, that is sensitive in wavelength less than 3 micrometer. So before 3 micrometer, we have only reflected component. So this is true in that case. What happens in the FOV, field of view of the sensor, when it looks toward a specific ground resolution cell for a given time delta t that we call dwell time while discussing in the previous class. We already discussed about it, like what is a way the sensor collect the data from the different ground resolution cells from the ground surface. Okay, so at one particular at a one particular time, for a dwell time delta t, the sensor looks to a particular cell on the ground, and the total energy which is outgoing from the cell and which are there within the FOV of sensor is collected. But in that FOV, there is also a contribution of atmospheric scatters. As you see over there, we call them path radiance. So the total radiance, total energy that is collected at the sensor is the actual energy which is that is outgoing from the surface, as well as the energy that is there in FOV from the atmosphere itself. So this is the reason why the heading of this discussion is atmospheric influence on the spectral response pattern. And if you remember, while discussion of scattering, I told that in Rayleigh scattering, we have a significant scatters which falls in the FOV, and they contribute to the total total energy reaches at the sensor, and they are responsible for the hazing effect. A kind of layer is there over the image. Okay, so the image clarity is degraded due to the haze effect, and the haze is due to the Rayleigh scattering, where the scatters are there and they falls in FOV of sensor, while sensor sensing the ground resolution, the picture element are ground resolution cells. In the previous few lectures, we have been discussing about what happens what are the steps at the sensor? When energy is collected at the sensor, how that energy is converted into the uh, digital number, and how the digital number is recorded on the storage device, and how we can visualize the DN numbers which are stored in a binary number format. Once we open that image on the screen, how we see the different sets of gray color if we visualize a single band image. So this part, data acquisition and interpretation, tells you uh, it is a discussion on the image characteristic of the image. When the image is acquired, what do you mean by pixel? What do you mean by picture element? A rows and column. Okay. So how we define the dimension of image? Okay. So they are defined in terms of row and column. And what is the representation? Like what kind of information digital number represent? That is discussed over here. And finally, they talk about analog to digital conversion. And as you see in the figure 1.13, so it's they have plotted this transfer function for A to D conversion, where if you see on the x-axis, they talks about time. On the y and left hand side on the y-axis, it's the input voltage, while on the right hand side, they talks about the digital number. Okay. So with respect to the continuous signal that is received at the sensor, how it is converted from analog voltage to the digital number, it is mentioned over here. So the way I discuss A to D conversion, that is bit different than the given over here. So you can also go through this concept. The basics of GNSS concept is covered over here. Then entire overview is given in 1.8, the ITL remote sensing system. Okay, what are the various components are there? If you see the figure 1.18, so they talk about major components which are involved, and which require the in-depth discussion. So energy source, interaction in the atmosphere, interaction with the target, then final step is sensing the energy at the sensor and recording the information in the storage device in terms of binary numbers. Okay. So if we move to the next unit, third is basic principles of photogrammetry. That is let me open the index. So briefly, I discussed about the content of chapter 1 and how much part can be referred, and which are partially covered, which are completely covered in our discussion, in addition with a few more concepts, a few more elaborated discussion. And I just suggested you in the beginning of this lecture, like first you should go through the chapter 1. So now I'm discussing on type of scanning system. Okay, and you can get you can get discussion on that in unit 5. If you refer section 5.1 to section 5.5, so there you will get discussion on what type of scanning system we have in terms of their architecture. Okay, the way the sensors operate. Okay, what is the internal design of the sensor? How they operate, how they collect, how they sense the picture element. Okay, that discussion is given in this 5.1 to 5.5. And right now we have been discussing on these concepts. Okay, so I hope this will help you to go through this book, and you can get a discussion, part of the discussion which we have been doing. Uh, so now I will start with the discussion which we left uh, in the last lecture. Okay, please wait.